Okay, so my first problem is problem 41, and 41 reads, the 1 kilogram physics book in figure P741 is connected to a string to a 500-gram coffee cup. The book is given a push up the slope and released with a speed of 3 meters per second. The coefficients of friction are US equaling 0.5 and UK equaling 0.2. Part A asks, how far does the book slide? So with what we're trying to find, which is the distance that the book slides, we know that we're going to need a change in x, and we're also given a velocity. The final velocity will be 0 because it'll come to rest at the top of the slope. And then it gives us our initial velocity as 3 meters per second. And then we have to find our a. So our change in x equals our initial velocity squared divided by 2a. And we have our free body diagrams of both the book and the cup. So for finding our acceleration so that we can find our change in x, we can figure out all of the forces that are going to help send our book down back the slope. And we'll have that the y direction of the mass of the book multiplied by gravity, as one force that'll add to our acceleration. And then our friction, which we can get our UK from the givens, and then we had to figure out what the net force was, and our net force is equaling the mass of the book times gravity in the x direction. So we have our mu multiplied by our normal force, and then we have our tension, because our tension is pulling the book downwards also, and we can find from this equation up here that our tension is equaling the mass of the cup times the acceleration, and then the mass of the cup times the gravity, which happens to be very similar. So now with that, we can factor out our mass of the book times gravity with our sign and our mu kinetic plus our multiplied by our cosine, and then we have an acceleration here and an acceleration here, so we want to get those on the same side, so we can factor that out. So we move this acceleration for the cup over with the acceleration of the book. We can factor out the mass or the acceleration and then divide our masses over. So we get that this equation here will give us our acceleration, and we just start plugging in the things given. So we know that the mass of the book is 1 and gravity is 9.8. So we know that this mass of the book times gravity will be 9.8. And then our angle is 20 degrees given by the problem. So we have the sine of 20 plus our coefficient for the kinetic friction, which is 0.2 multiplied by our cosine of 20 plus the gravity multiplied by the mass of the cup, which gives us 4.9. And then our two masses added together are 1 kilogram and half a kilogram. So we have 1.5 kilograms. And we get that our acceleration equals 6.73 meters per second squared. Now that we have that, we have our initial velocity of 3 meters per second, 2 multiplied by our new acceleration that we have, and you find that your change in x is 0.668 meters. And then part B asks, at the highest point, does the book stick to the slope or does it slide back down? So there are three things that are three forces that will either help the book stay up or slide the book back down. And that's our static friction, our tension, and then our gravity. The gravity has a component that will push it along with the tension, so we need to find that. And then once we have that, we can add that part of the gravity to the tension, and if that is greater than our static friction force, the book will slide down. So our static friction equals mu s times the normal force, and as we found in the previous part, our normal force is the mass of the book times gravity times cosine of our angle, which is 20. So you have 0.5 multiplied, or 0.5 is the static friction coefficient multiplied by our 9.8 cosine 20, which gets you that the static friction is 4.61 newtons. Our tension is our cup's mass multiplied by gravity, which will get us 4.9 newtons. So by itself, tension will overcome the static friction. But if you add the gravity exponent of it, which happens to be 3.35 newtons, which you get from the mg of and then sine of 20, you get that our 4.9 plus our 3.35 will be bigger than our 4.61, so the book will slide down.